Right, today is day 6 of, day 6? Yeah, day 6 of unit 12, our last unit. Today we're going to talk about the correlation coefficient. As always, let's go over our homework first. So you guys first had to do questions 3 and 4 on page 22, I believe. Both multiple choice questions. So for this one, for number 3, the answer was 2. So if you read through this, so given the information, which statement can correctly be concluded. So I actually read these first before I even looked at the graph, and then kind of worked backwards. So eating more ice cream causes a person to become thirsty. So that doesn't tell you anything about being thirsty. Kind of the same thing as drinking more soda causes a person to become more hungry. That's not really something you can get from a graph. The only thing you can do is you can talk about the correlation. So there's definitely a correlation, but there's not a causation. So if there was a causation, then that would be 1 and 2, but there is not. So it's so it might be a coincidence, and yes, maybe you personally are thirsty when you drink, but this graph does not tell you that. All right, 4 is number 4. So this had a negative correlation. So I know it's very hard to see these graphs, but clearly you can see this graph is kind of just all making a straight line this way. There's definitely no correlation here. This would be positive. So number 4 would be the only one that's negative. And then lastly, you guys had to do number 4 on page 24. You had to put miles driven into L1 and the number of gallons used into L2. When you did that, this would come up. I haven't talked about this yet, so yours probably didn't come up with this yet. This is the correlation coefficient. That's what we'll be talking about today. So the big thing here is to make sure that you guys write down what you get in your calculator, and then you need to correctly round to the nearest hundredth. Please be careful with that. Okay, so it was 0.05x minus 0.92. If you put a little 0 in front, even better. Okay, so what we're going to talk about today is the correlation coefficient. So what the correlation coefficient tells us is basically without creating a scatter plot, so we still have to use our calculator, but without creating a scatter plot, we can figure out if the correlation is strong or weak, or if there isn't one at all. Okay, so again, all of these start the same exact way. And so this one we're just going to focus on reading it, but basically the new thing today is this diagnostic on. So what you're going to do in your calculator, and you're going to have to do this every time, especially after you restart the calculator. So you always have to do this. So you're going to go to second, and then if you look right above the 0, it says catalog. Okay, and then it's going to come up like this. Okay, so what you're going to do, and this is super annoying, but you're going to scroll down all the way until you see diagnostic. Okay, so what we want to do is we want to turn our diagnostics on. So what this does, so you're going to press enter so it comes up, press enter until it says done. You should only have to do it once, but press enter when it's done. So basically now what's going to happen, and I kind of talked about this already, but now when you guys do these, when you do your linear regression, it's going to come up with a few more things. So you're going to have your A and your B. So remember that A means slope, the B means y-intercept. Actually, I'm just going to have it already typed up. I'm going to put that up for you guys so it's a little bit easier to see. Okay, so again, this is your slope. So anything in a box is something you need to write down. So this is your slope, this is your y-intercept, and then this we don't really care about. We want our r, unless they ask you for r squared, but we want the r, okay? So for this one, because it's positive, okay, that means it's going to be a positive correlation, and the closer it is to 1, it means strong. So if it's close to a -1, it's a strong negative relationship, and if it's close to +1, it's a strong positive relationship. So again, just for another reminder of how to write this, you would just expand the whole thing. Also, be careful with that because usually they don't ask you to write out the entire thing. They tell you to round to the nearest blank. Okay, so now we're going to talk about what the correlation coefficient, what it represents. So again, I'm just going to do this so I can talk about it as we go over it. So a correlation coefficient is represented by R. I know, super weird, but that is what it is. So when we're talking about the correlation coefficient, it's going to be between -1 and 1. Because remember, we're talking about a straight line, so it's going to be between -1 and 1. So if it's positive, it will look like this. So if it's perfectly in a line, that would be a perfect positive correlation. Probably not going to see that very often, but that would be a perfect positive correlation. Strong would be, it definitely makes a very nice line like this. And if it is weak, it's going to be spread out, but still it has the general direction, just like all of these, that they're going all in the upward direction, and they are diagonal, right? Okay, so start low, go high. Now for the negative correlations, these are all going to go in the downward direction. And again, the closer the dots are together, the stronger the relationship is. And then if there is no pattern that you can see, that would be no correlation. Alright, so here are our fits. So a good fit would be between 1 and -1. I'm sorry, either or, you can't be close to either of them. So it's going to be, so 0.9999, that would be a super, super good correlation. If it's not a good fit, it's going to be closer to 0. A perfect fit would be exactly 1 or -1. Remember, the negative talks about a negative correlation, positive is a positive correlation, if you remember. Strong would be anything greater than 0.8. Okay? And then weak would be less than 0.5. So again, if you're closer to this, then we're going to say strong, and if it's 0.5, that would be weak. Okay. All right, so we're going to do a little bit of matching. So for our scatter plot, we have A through F, and we're going to match them with the coefficient that belongs. So, okay, so we have, so first of all, notice that we have positive and negatives. Let's start off with 0. So if it's a 0, that would be the one that has no correlation. So that one would be B. Okay. Now we have a 0.50. So that one's going to be a weak correlation and positive. So the weak correlation that's positive, that would be D. Okay, so it still goes up this way, but our dots are pretty spread out. So negative 0.85. So that's going to be on the strong side, but it's going to be negative. So that one would be E. 0.92, that would be strong and positive. So that one is going to be A. 1 would be perfect, it's positive, so it's going to be C. And then this one would be weak but negative, so that will be F. So again, just to recap, so this would be strong and positive. This would be none. This would be perfect, positive, weak, positive. So if people aren't listening and copying, they're going to think I spelled perfect wrong and added all these T's, but really they're plus signs. Okay, this is going to be strong, negative, and weak, negative. Alright, so here's another type of question they might give you as a multiple choice. Is they want which one is the strongest linear relationship? And it doesn't matter if it's positive or negative, it just wants it to be the one that's, so we don't care about any of this stuff. All we care about are the R's. Okay? So I want the one that is the closest to 1. So this is the smallest. And those are smallest, so D would be the correct answer. D. And remember, all you're thinking of is which one is closest to 1. Okay, I want it to be closest to 1. This one is clearly closest to 1. They're pretty close. So basically they want you to understand, now they did, let me erase this for a second, they are making sure that you know that the correlation coefficient is an R, because, I mean, look at Look at the A value. They might be trying to trick you right here because that's really close to a 1. So maybe they're thinking that you'll click C. So think of the distractors that they might give you for these questions, and it might help. All right, so we have another correlation coefficient, and we want the linear fit. So first we should look. So we're going to cross off 1 and 2. Hopefully you notice this is going down, so it's definitely going to be negative. Now, what you also need to be thinking of is this perfect? So if you wanted to, you could take all of these coordinates and actually find to the nearest hundredth. But this is multiple choice. This means perfect. This by no means makes a perfect line. So honestly, there's no reason to do more work. This is negative, it's close, so it's strong, but it is not perfect. Okay, so 3 would be the correct answer. All right, so we're going to do, I think we're going to do 2 examples. Yeah, 2 examples where we're going to use the actual calculator. Okay. So the question wants us to find the linear correlation coefficient. So if it ever says linear regression or linear correlation coefficient, you guys should automatically put these, unless you can tell, just like we just did, if you can tell based on the graph or a chart or whatever, then you can do that. But when in doubt, you can always put it in your calculator. So just to recap what we did a couple minutes ago, you press second function 0. It'll bring you to the catalog. Now, we just did this, so if you did that when I did it earlier, you don't have to do this again. But I just want to show you again, just so you can try to commit it to memory. Okay, so you want to turn your diagnostics on. And again, once you turn them on, they are on, unless you, clear your calculator or your memory. Okay, so let's go to Stat, Edit, and we're going to just put these into L1 and these into L2. So 3... Oop, not plus. So 3, 4, 5, 6. And just to recap again, after you click one, you press enter and it goes to the next one. 9.25, 9.5, 9.75. Okay, so after you do this, everything else works the same as a linear regression. But now we turn the diagnostics on. So again, go to Stat, Calc. And then we're going to go down to number 4. Okay, so here's the thing is it doesn't tell you to do a linear regression. It says linear correlation coefficient. So you need to know that if it asks you about a correlation coefficient, it wants the regression. So correlation, regression, you should think those words interchangeably just so you can remember this part. Okay, so you're going to do that. Our diagnostics are on, so now we should get all 4 numbers. All right, so when you do that, you actually see that our R value is a perfect 1. So I would actually write that down on your paper. Okay, so again, I just wrote down what we put in our calculator. When you get a question like this on the region, now this is a multiple choice, so that's kind of irrelevant. But if you get a question like this on the region that's not multiple choice, please write down everything that you get from your calculator, just to ensure that you don't transcribe something wrong and get points off. Okay, so again, I want to do a couple more examples, maybe just one. If you can't read these, just make sure that you copy it down right as I type them in, because I'm sure you can see my calculator better than what's on there. Okay, so for this, again, we are going to, so it says to find the correlation coefficient for the line of best fit, and we want to explain what that means. So when it says explain, we're talking about what it actually means with the bivariate data. Remember the 2 different variables. Okay, so let's go to Stat Edit and go ahead and clear these. Remember, you go up to L2, press clear and enter. Go up to L1, clear, enter. Okay, so go ahead. This is 186. Normally I would pause it and do this for you guys, but just to make sure that you can see those numbers. I do apologize, they did come out not so great. Oop. 139. Okay, so there's my 8 there. 495, 477, 425, 322, 482. And again, you guys shouldn't just be copying down the answers, you really need to commit this to your memory because there is no shortcut way to memorize this. You need to practice. And there will be questions like this on the region. Okay, so now we're going to look at the correlation coefficient. So we're going to go to Stat. We don't have to turn our diagnostics on because they already are. So I'm going to do the linear regression again. Press Enter, Enter. Remember, if yours makes you calculate, then just go ahead and calculate. Okay, so now what we have is we have our line of best fit. So remember, you just rewrite that in. So it's to the nearest hundredth, so make sure you write to the nearest hundredth. So the answer for this would be 0.94 would be your correlation coefficient. And to explain what this means, so it says a nutritionist collected information about different brands of beef hot dogs. She made a table showing the number of calories and the amount of sodium in each. So the correlation coefficient suggests that calories increase. So if calories increase, then so does the sodium. So there is a strong positive correlation. Because it's a strong positive correlation, basically it just means that as one increases, the other does as well. Now you have to say it in this order because remember, so my calories rely on, the sodium relies on the calories. So this would be your X and this would be your Y. So make sure that you write the correlation coefficient suggests that as the calorie increases, so does the sodium. Not as the sodium increases, so does the calories, because that's not dependent on each other. It's the other way around. Okay, so what I would like you guys to do now, and I picked this one because I think it's easy for you to see, but I will do this just in case it's easier for you to see on this paper instead of your own. You are going to do question number 6 on page 28. What I want you to notice is you are rounding. You are rounding 4 decimal places. Okay, so you're doing a linear regression. And you are going, now, so this one is kind of backtracking, so you don't actually need R, but I want to make sure that you can expand on this. So you're going to do the linear regression, and then you're going to use the equation to determine in what year the fireworks will have reached 99 million. So basically what you're going to do, okay, so to complete number 6, I left a couple of notes for you. First things first, I want you to notice that there is no X and Y in this, it's P and T. So make sure you see that X goes with T and Y goes with P. So when you write your final equation, please make sure you write P equals, and then whatever the A value is, T plus, and then whatever the B value is. Okay? And again, 4 decimal places. Then once you have A, so A is going to be an equation. Okay? So P equals 2x plus 9. I don't know, something with millions of decimals. So you're going to round to 4 decimals, and then you're going to use that equation, and you're going to plug in 99 for P, and then solve for T. Okay, so I want to know after how many years would they reach 99 million? And you're going to get, obviously, so if you look at this, so we have 67.6 here, 88, and then we go up to, so it's going to be between 2 and 4. Okay, that just makes sense. But you're going to use the equation that they gave you, and then so you're going to say after how many years, and then they want to know what the year would be. So notice that this is at 1990, so I'm basically giving you the answer. So after 1990, how many years, and then you would add how many years to 1990. So you should say that it will reach 99 million in 1990 blank. Okay. Okay, so number 6 kind of just talks about what we did yesterday. So what I want you to also do is number 7. So again, you're going to put these into your calculator. And for this one, I just want the correlation coefficient. So the correlation coefficient, so the R, okay, and it needs to be around 4 decimal places. So your homework would be page 28 numbers 6 and 7.